All right, so Unit 4, we're going to start with Lesson 4 on properties. Let's do a quick review. Do this out loud together as a class. Number 1, log base 4 of 16. Answer is 2. Number 2, log base 8 of 1. Log base 2 of 1/16. Log base 4 of 32. Silence. What's the thought process? What are you thinking out in your head? 4 to what power gives me 32? Can I convert to a common base? 2. 2 squared times x is equal to 2 to the 5th. What's x? 5 halves. We're good with that? Everybody? All right, last one. Log base 5 of 32. Can you tell me the two integer values that it would fall between? It's going to be a decimal. Here's what I mean by that. 5 to what power gives me 32 has to fall between what two integer values? 2 and 3, right? 5 squared is 25. 5 cubed is 125, so it's somewhere in between that has to generate the 32. This is going to be our introduction to today's lesson, which is if you come across a log that you cannot think out, we are going to use the change of base formula moving forward. The change of base formula says this. Notice this is what I'm going to call the answer. This is the smaller base. You can split a single logarithm into two separate parts in a fractional form. You can put in your calculator the log of x over the log of a. What does the base then become in both of those? This was base a. This is now base what? These are both base 10. You also have the option of choosing natural log. So you could do base e for both of them, but the bases need to be the same. So this is how we're going to go and actually calculate that. Now, here's my heads up to you. I explained that there is a section of the test that is no calculator. Let's say we had that last example, which was log base 5 of 32. If I gave this to you on a non-calculator portion of the test, it's because I want you to tell me that that's the same thing as log 32 over log 5, or natural log 32 over natural log 5. Notice I wrote log twice. It's two separate logarithms combined into one fraction. Some of your calculators will allow you to manipulate the bases down here in some of the menus. Some of them don't. So it's not fair that I give that to you and ask you to evaluate it when you all don't have that as a tool on a test. So that's why if you have this scenario happen and you can't think it out, you want to go to here. Questions on that? Symbolic form. Yes?
So you can do this in log 10.
That the answer comes out to log 10, you mean?
No, if it is. Instead of 5,
Well, yeah, so you could do log of 32 over log of 10, but remember log base 10 of 10 is 1. So it's doing the same thing. Can you see that in your head, what I'm saying? Yes? When you do split it into that fractional form, like this, the denominator takes on the value of 1 with a log base 10 of 10. Questions. Change of base formula, super powerful. So I think, in your notes coming up, let's see if this is right. We can evaluate. Log base 2 of 8, what's the answer? 3. Okay, so we know that. Just as a verification, pull out your calculator. Please type in log of 8, parenthesis closed, divided by log of 2, parenthesis closed. We're using the log button right here, log, on the far left. Does your calculator give you 3? Some of you are like, I'm not even going to put it in. I know it's 3. It's going to be 3. Now, this is where, in example 2, some of you really have to slow down your thinking with logs. You know you think in multiplication. So when you read this, you're saying log base 3 of 15. Oh, the answer's 5. No, it's not 5. That's 3 times 5. What I'm asking you for is what is the exponent of 3 that gives you 15? It falls between which two integers? 2 and 3, right? It's between 9 and 27. So your answer should come out to a decimal bigger than 2 but smaller than 3. Put this in your calculator. You can use the change of base formula. Personally, I always use log base 10 just because it's easy just to remember one formula. What do you get? Log base 15 divided by log of 3. 2.465. And that makes sense. It falls between 2 and 3. All right, real quickly, 3, 2, 1. How many are 3 with this? Super easy. Why am I even wasting my time having you take an assessment? Okay, good. Here we go. Moving on. Properties. We have done all 4 of these, so you can quickly copy them down. The first one is the zero exponent law, written as a logarithm. The second one is the fact that base to the first power gives you back just what you started with. Natural log of e is 1, right? Because what is the understood base? E to the first power is e. Power to power rule, we did that one. And then we also talked about the fact if you have 2 exponents that are equal, then that means their bases were equal to start with, which is what I have here. AJ, go.
For the last one we just did, do you always want like 3 points after the decimal?
No, but it is advised whenever you're doing word problems with logs because the decimals, truncating, cutting decimals down affects the calculations over long-term years. Think about like the money examples we talked about, that you at the very least use 3 decimals when you're dealing with logs and exponents or formulas. These 4 we've already covered. You have them in your notes previously. I'm just putting them in a condensed form because I'm going to add 3 more rules to it. Are you ready? Are you ready? Anybody ever play t-ball when you were little? Yeah? T-ball? My brother used to play. My brother's like huge. He was real little, so he was real big when he was little, so they made him the catcher, and it was the cutest thing. They always wore all the gear for t-ball, and he would like take the ball and hold it up and be like, are you ready? Every single play, and then he would put the ball on the tee, and he would go back and squat behind the plate. Dude. Whatever. He grew too fast, he blew out his knees. Catching was not his forte. All right, next rule. Here we go. Property of logarithm. Write it down. I'll explain what it means. Log base a of uv is equal to log base a of u plus log base a of v. All right, when I say log, what should you replace it with? What phrase? Log means the exponent of. So think about it. The exponent of this that gives you the product is equal to the exponent of this plus the exponent of this. Here is our example of that. If I want to take 9 times 27 in the answer spot, okay, and I pick nice numbers so you could like understand and think it out on your own, log base 3 of 9 plus log base 3 of 27, isn't this just the product rule of multiplication? With like bases, you add them. Right? Think about it. 3 squared times 3 to the third, doesn't that equal 3 to the what? 5th? You add the exponents when you multiply.
Yep.
When you multiply, you add the exponents. That's the law. That's the rule written as logarithms. So this is the exponential thought process. This is the translation to logs. You don't need the red. I just really want you to have the black. All right, now take a look at the next one. Logarithm base a of u divided by v. It's going to be the subtraction. 2 logs. Here's our thinking example. 27 divided by 9. 3 cubed divided by 3 squared. Doesn't that equal 3 to the first because we subtract the exponents? Same exact thing. Get it? But the key thing here is what I'm saying. When you add the powers, it means you're multiplying. When you subtract powers, it means ultimately you were dividing. Like those are the key ideas that we're doing here. Right? And then we can do this one, which is the power to power rule. Power to power rule says this. If I take 27, what am I doing? If I take 3 to the third and I square it, don't I multiply 3 times 2? Gives me 3 to the sixth. That's that idea, power to power rule. This one comes up a lot. I'm going to put a star by that one. Last property. This is it. No other properties. Here's a numeric example. If I take 9 squared, I get 4. Again, you don't need to write any of the red. It's just a thought process at this point. Goes back to what we know here. So we have multiplication of powers, division of powers, and product rule. Power to power. Keep those exponent rules kind of flowing in your head. Because we are going to do this. We are going to use the properties to expand. Expand means to go from 1 log to more. Okay? More than 1 log. Now, those of you who have not been paying attention, please check back in. What I just put a box around is the answer spot of a log. I'm going to ask you this question. How many bases are in the answer spot? How many bases? 3. That's why I said pay attention. In the answer spot, there are 3 bases. I'm going to write that right above here. 3 bases. Okay? They are the 8, the A, and the B. The number of bases tells you how many logs to expand to. So I'm going to have log base 2. I'm going to have log base 2. I'm going to have log base 2. This is multiplication in the answer spot, which means I'm going to be adding the logs. I've got log base 2 of 8, log base 2 of A to the 4th, and log base 2 of B. The number of bases tells you the number of logs to expand to. Once I have done my expansion, I then need to apply my last property, which is the power rule. And the power rule says you're going to take anybody who still has an exponent in the answer spot and bring it out front. Can you simplify log base 2 of 8? Yes, what's log base 2 of 8? 3 plus 4 log base 2 of A plus log base 2 of B, and I'm done. Nothing else can be done with those. I've expanded from 1 log into 3. For those of you that are going to maybe go back and rewatch the video for this section, the ones that you want to convert into their other form are simple ones that you can think out. If this was a change of base, if this was log base 2 of 10, don't go to the decimal form. Leave it in log form. But if it's something that's easily converted, please do that. Okay, you'll recognize them, they'll pop out at you. All right, let's go to the next example. Expand. Example 4. All right, now I'm going to ask you this in the answer spot. How many bases are there? There are 2 bases. Okay, so those of you, again, who have not been kind of checked in, come back here. The first base is a quantity. Anytime you have adding and subtracting, it gets grouped into one base parenthesis group. My second base is going to be just the 5. So this one only has 2 bases to deal with. Okay. Now, the first thing I'm going to do, just so that the thought process is there for all of you, is, why did I write it like that? 9x minus 2. I'm going to take my bases and use all exponents, no roots. So I have 9x minus 2 is one base, raised to the 1/2 power. And then I have the 5, which is raised to the 1st power. In my answer spot, I have division. According to my properties, division of logs or exponents is what operation? Subtraction. So I'm going to have ln of 9x minus 2 to the 1/2 minus ln of 5. And like the last problem, I'm going to take that 1/2 and move it where? It's going to be moved out front, correct? 1/2. So this is now gone. So I have 1/2 natural log of 9x minus 2, which is a base that stays together. I can't split the 9x because there's a minus sign with it, and ln of 5. What questions do you have on this example? Because we're going to change and do a different type. Yes, ma'am. Yep, we took this. This was a 2. This is to the 1st power, and then I converted it into its rational exponent form, or fraction. Right, so this is then gone in my final answer, and that's what I would get. Expanding. From what I'm told, this is one of the more confusing things you did last year. Okay, good feedback, thanks. Let's move on. Now we go in the other direction. We're going to use our properties to condense. Right? Condense means go from many logs to 1 log. Many logs to 1 log. So if I look at this, I have 2 logs. By condensing, I'm going to turn it into 1. I'm going to do the process in reverse. I'm going to bring this 1/2 back up top, ln a to the 1/2. I'm then going to say to myself, oh, this 2 has to come back up here. So I'm using the product rule, or not the product rule, excuse me, the power to power rule, bringing everybody back in. I'm now going to convert ln here. And since I'm adding, am I multiplying or am I dividing in the answer spot? Multiplying. So I'm going to get in my answer spot a to the 1/2 times x plus 4 squared. However, if you look in the last example, we didn't use fractional exponents. We used roots. So your final answer will have roots when you write it as 1 log. Do I need the 2 here? Do I need the 1? No, I just put it there to tie into the previous question that someone asked, Haley asked about the exponents of roots. Okay, there was a little chatter going on about not understanding something. Did we figure it out? Does anyone have a question? I'm guessing this is going to seem really easy when I do it, yes? It'll be easy for you too. You'll get it. Good? Good? Questions? All right, here we go. Moving on then. All right. Using the properties to condense. Normally, I would say, you try this problem and you're going to write it down, and then half of you won't get it right and you'll get really frustrated. So what I would prefer to do is I'm going to take you down the path. I'm going to show you what you should be looking for, etc. What was my first step in the last problem? bring back in what? Bring back in all my exponents. So I'm going to get rid of this 5. I'm going to bring it up here. I'm going to get rid of this 4. I'm going to bring it up here. I'm going to get rid of this 2. I'm going to bring it back up here. Okay? Next question. Do all of my logs have the same little base? Log base 5, log base 5. I don't think I mentioned this before, but you can't condense logs into one log unless they all have the same base. All right, so it's just understood. I kind of took it for granted, but I want to make sure I say it at least one time, that you have to have the same base down here. Now, here's the tricky part. How many logs do I technically have on the board right now? Okay, 3. So what I want to do is I'm going to box them out for you. We've got the first log, which is here. Second log, which is here. Third log, which is here. Okay? Do you remember this property? A plus B plus C? Yes? Okay. A plus B plus C is the same thing as B plus C plus A, correct? When you're adding and subtracting, you can change the order. Keep that idea in mind. Couldn't I take this block and put it first, and then move this one here with a plus sign in front? Right? A, B, C, you can add them together and change the order. So the question then becomes, what do the plus and minus signs really mean about addition and subtraction when it comes to multiplication or division? You know what I'm saying with the product rules we just talked about? Like, what does it really mean? And I'm going to tell you what it really means. Here's your rule. If there is a plus sign in front of the log, it goes in the numerator. If there is a minus sign, it's going to go into the denominator. So I'm going to keep my logs in the same order. I'm going to look at this. Just to bring this to the 4, x minus 4 to the 5th, minus log base 5 of z to the 4th, plus log base 5 of y squared. I'm going to create one log, log base 5. I'm not doing log divided by log, it's one log. I'm going to draw a fraction bar. This is a positive log, which means it's going in the top. So this goes up here, x minus 4 to the 5th. Minus log means it goes in the bottom. So I'm going to put z to the 4th in the bottom. Positive y squared is going to go up top. Whenever I used to assign this problem as classwork, as soon as students saw a minus, they took all of this and put it in the bottom. The y squared has a positive coefficient, therefore it belongs in the top. Okay? I'm going to erase this answer in 1 second. Let me go back and make sure everybody gets that copied. Are you good with that answer? Okay. You will get complicated problems that look like this. There is a plus sign here. There is a minus sign with brackets. This one goes in the top. This means take anything that's on the inside and put it in the bottom, because this is a plus sign here. So z to the 4th would go to the bottom times y to the 2nd. This is different than the problem that I gave you. Grouping symbols do apply when we talk about logarithms. Okay? So there's your review of the different properties. Turn the page, and I'm going to ask you to solve this equation. How do you solve x to the 4th minus 5x squared plus 6 equals 0? This is not a quadratic. This is a quartic equation. So we are going to use a quadratic strategy. How do you solve that? Factor into, go ahead, x squared, oops, let's not bring it all up at one time. X squared, minus 2 equals 0. Now what? How do you get the 2 answers for each quantity? Because there's 4 solutions if it's x to the 4th. How do you generate the 2 solutions? Yes, ma'am. And? Correct. So, here's my work for this. I'm going to erase that. I took each quantity, I set it equal to 0, I took the square root of both sides, right? I went like this, but it's plus or minus. And I came up with my 4 solutions. Yes, you need to know how to do this without a calculator. We had examples of this in the last unit when we were finding zeros by hand. Calculate the zeros by hand. Obviously, we're going to use this in this section. That's why we did it as a warm-up to the section. Moving forward, to solve an exponential. Here you go. Get the exponential term by itself. You can rewrite as a log. Solve for the variable that you're asked. If there are 2 exponential expressions, take the log or ln of both sides of the equation. We're going to do examples of all of these if you want to jot this down. My sister over there. Have you seen her? She looks just like me. Tall. Went to the same college. She's like a year younger than me. Didn't know her. All right, here we go. Exponential. Here's my question. How do I know I have an exponential equation? How do you know it's not rational or quadratic or linear? Exponential because is where? X is in the exponent. Take a look. X is in the exponent, which means it's an exponential equation. So the first type we're going to talk about is 1 exponential base. You're going to say 1 exponential base. Yes. E to the 2x is my 1 exponential base. Just like linear equations, we want to isolate the exponential base. So how do I do that algebraically? Add 4, divide by. Okay, so now we're going to see something else new here. Here's the new thing. Don't go to decimals. Leave it as fractions. The calculator is going to do the work for you. Okay, so my step number 1 is isolate the base, exponential base. Now my next step here is going to be what? We're going to convert. So let's come over here and let's talk about this kind of gig that we have here. Base to the power is equal to an answer. What's the logarithmic form of that? Log base what? In this one. Log base square of circle is equal to parts. I don't care what's in those locations. They could be shapes, they could be quantities, they could be any of that. You want to keep that movement around from one form to the other in mind. Oh, you guys needed a mental break. Sorry. All right, so let's recap. Sorry. Fast forward. All right, so we isolated the base to the power. We got to here. We then said, wait a second. Let's go over to this symbolic form of manipulation to go from an exponential to a logarithmic. So now, since I'm dealing with base E, I would suggest using natural log. Anytime base is E, I would go to natural log. So I'm going to say natural log. We know it's base E. If you want to write it there for now, you can. What goes in the answer spot? ln of what? What's the answer? 94 over 3 is equal to 2x. Do you notice now how you got the exponent out and just became a number by itself by converting the form? Last step is to divide by what? 2. Okay? So, when we do that, x is equal to, please put this into your calculator. Natural log of 94 divided by 3, hit enter, and then divide by 2. Do it in separate steps. What'd you get? Let's see if everybody gets that. 1.722. 1.72. All right, so now I'm going to ask you, does that make sense? If you need to, here you go. Base to the power is equal to the answer. There it is. Yes. You type in ln. Boop. 94 divided by 2, parenthesis closed. Enter. And then you divide by 2 last. Divide by what? The last one there. 94 divided by 3, and then divide by 2. Maybe I said 2 twice. It's probably my fault. All right, so type 1. Single exponential base. Fantastic. Next type. What happens when I have 2 exponential bases, like this? Well, they're going to come in a very special form. That special form is e to the 2x. It's a quadratic form. Take a look. Okay? It looks like a quadratic. We're going to first factor this. So I'm going to take the 2 quantities, and I'm going to say e to the x. E to the x. When I multiply them, I add the powers. That's where I get e to the 2x. What 2 numbers multiplied? It gave me 6, negative 3, negative 2. Does this look familiar from the warm-up? That's why we did the warm-up right here. Ching. E to the x is equal to 3. E to the x is equal to 2. Does that look familiar? Yes? But here's the problem. This is not linear or quadratic. These are exponential. How do I get the x out? ln of 3 is equal to x. ln of 2 is equal to x. How am I doing that? I'm doing base to the power is equal to the circle, and I'm rearranging it. I'm taking those spots and putting them in. So what's ln 3? What's ln 2? 1.09 and 1.60? Okay, so one thing to get used to, in calculus, your answers would be ln 3, ln 2. I'm asking you to go to decimals for now. That's pretty easy to just punch it in your calculator. It's an added step. However, the answers moving forward will just be ln 3, ln 2 beyond this course. Okay, so second type we have here is the special form of like e to the 2x, e to the x, and a number equal to 0. This is going to involve factoring. So that's our second type of exponential equation. Third type, here it is. How many bases do I have? 2 bases, 2 exponential bases. Okay, so here's third type of problem. Can I convert these to common bases? Do 9 and 8 have common bases? No, right? They do not. So what we learned way back when to think out isn't going to help us here. So, first thing. So. I'm going to put a note in purple. I Are you ready? Study this. Study this. There are some of you that will ask me questions about problems like this on your homework, on the review, on this, and I'll say, go back. It's in your notes. It's in your notes. Here it is. Ask if you don't understand, or go back and watch the video to this specific part. When you have two bases that are not the same, that do not involve the factoring problems, the easiest way to solve them, which is going to help you down the road for future equation solving, is this. Pick a base. So I'm going to pick 8 as my base. X plus 1 is going to be my exponent. That means 9 to the x is in the answer spot. See it for what it is. Base to a power is equal to an answer. Even though that answer has an exponent in it, don't panic. See the part. So we're going back to this blue definition right here. Now let's convert this. I'm going to do log base what? Log base 8 of what's in the answer spot? 9 to the x is equal to x plus 1. Yes? Base to the answer is equal to the power. The log is the power. So I'm trying to give you the symbolic form of this to reinforce it. All right, fantastic. How do we get the x out of the exponent? When you have a log, how do you do that? Can't you move it to the front with the power-to-power rule? We just talked about that. So I'm going to take the power-to-power rule, and I'm going to bring this out front. So I'm going to bring that x out front here. Yes? So now here's what I have. I have x log base 8 of 9 is equal to x plus 1. Are you good? All right. What is our goal to solve for which variable? X. X is involved in how many terms? 2 of the 3, correct? For those of you that don't see that, this is one term because there's multiplication. Here's a term, and here's a term. So look at the placeholders. In order to solve for x, they all have to be on the same side. We know this from previous problems. So I'm going to say, okay, x log base 8 of 9 minus x is equal to 1. Anybody have a question about that? I'm moving the people around. I'm putting all the x people on the left. All of your x people move to the left. Yes, sir. You cannot divide by x. If you divide by x, you get 1 over x, first of all, which didn't help you. And second of all, when you divide, don't you reduce powers of solutions? Like if I had x cubed and divided by x, it would take down the number of solutions. Never, ever divide. That was a good question because a lot of people will try to do that. I'm thinking now that maybe you didn't mean divide. Did you mean this? GCF? And the right side? But then you would get 1 over x. Some people use divide because that's the operation they think of for GCF. That's why I was checking. Your next step is actually GCF. Now I only have 1x. How do I get it by itself? How do I get x by itself? X times a quantity. X times a quantity. How do you get it by itself? Who has no idea what to do? Raise your hand. Be honest. No idea. Okay, so let's talk about this. X times 2 equals 1. How do you get x by itself? Divide by 2. Instead of a 2, I now have a quantity. So what do I divide by? The quantity. Divide by log base 8 of 9 minus 1. Divide by log base 8 of 9 minus 1. Now, for some of you, here's where things kind of go off the tracks. Right here. This is where the misunderstanding of the work starts to happen, and this is the reason why. Log base 8 of 9, isn't that a decimal? It's like 1 point something. 8 to what power gives me 9? It's 1 point something. If you were using the change of base formula, you would have figured it out. We're not using the change of base formula. We're keeping it as like a 2. This is a decimal times x minus an x. That's why I'm able to factor out the x. From there, then, I divide by the quantity so that I isolate x. So now I'm at a point where I get x is equal to this. What I'd like you to do is to put that in your calculator. 1 divided by log base 8 of 9. And remember, when you're doing this, log base 8 of 9 minus 1, you need to try to figure this part out. This is tricky with the parentheses. Let's see if you can get it. Yes, sir. 17.6? 17.7?
-0.05.
-0.05. All right, here's the easiest way to do this. Take a look up here on the board. What if I put the denominator in first? I use the change of base formula, log of 9 divided by log of 8, right in the bottom. Subtract 1, I'll get a decimal. And then I'm going to take 1 divided by this answer. Isn't that the same thing as what I'm doing right here? What do you get then? Those of you who have fancy calculators that you can put exponents and change log bases, it's very easy for you to put this in your calculator. For the rest of you, you're going to have to try to figure out another way. This would be the easiest. Log of 9 divided by log of 8, change a base formula. Get that answer, subtract 1, and then do 1 divided by that decimal that you got in the previous part. What do you get? 17.67? 7.6. Now let's put it all in. Let's get it. 17.65. 17.65.